Hi there, it's Chris here from Technical Networks. The purpose of this video is to show you how to configure NAT in Packet Tracer. NAT stands for Network Address Translation, and NAT is used to translate private IP address into public IP address. Because in order for us to communicate on the internet, we do need a public IP address. And there are three types of NAT. We have static NAT, dynamic NAT, and NAT-PAT, which stands for NAT port address translation. So static NAT is going to be our main focus for today. So on static NAT, what it does is it provides a one-to-one mapping of a local IP address, which is a private IP address, to a global IP address, which is a public IP address. And static NAT translation is also bidirectional, so which means that either if traffic was generated by the external or internal host, the packet will pass through NAT. So we're just going to be jumping into action quickly. This is the topology we're going to be using for today's video. So basically what I've done so far is only to assign IP addresses in order to save us time. I've assigned IP addresses to the host, to the PC, to the servers in a local network and on the internet as well. So we've got IP addresses assigned to these two interfaces as well. So, and these are we're going to simulate this as the internet, that's the ISP router, and these are our local router here. So we've got two public IP addresses from the ISP. So we're going to be translating the IP address of this server, which is 192.168.10.6. We're going to be translating that to 54.1.1.6. So the purpose of NAT mainly is to advertise our internal servers to the internet with a public IP address. So to make it accessible for people on the internet, basically. So we're going to be jumping into action. The first things first, what I'm going to do is I'm going to verify our IP address. So show IP interface brief. Okay, so we are good. So what I'm going to do is to create a default static route from here, from our network here to the ISP, so we can have connectivity to remote networks on the internet. So I'm going to say conft. So I'm going to say IP route 0.0.0.0, 0.0.0.0. Then the next stop will be 201.145.12.2. Yeah. So, and then from the ISP router, because the ISP router does not care about knowing about our private IP addresses. So I'm going to be creating a static route to the public IP addresses that has been given to us by the ISP router. The ISP wants to reach our network through these public IP addresses. So I'm going to be creating a static route to that network, and our next stop is going to be this interface. So I'm going to say enable conft IP route. That's the network is 54.1.1.0, then that's 255.255.255, say /24, then 201. Next up is .145.12.1. So yeah, that is that. So what we need to do now, after that is done, we need to identify our inside interface and our outside interface. In NAT, the interface facing our local network within our inside network is the inside interface. And then the interface facing the ISP or the internet will be our outside interface. So this interface here is gigabit 0/0. I've just removed the port labels because they were obstructing, blocking some things there. So yeah, so that's interface gigabit 0/0. So I'm just gonna go there quickly. Interface gigabit 0/0. So I'm gonna say IP NAT inside. So that's our inside interface. We've identified that as our inside interface. Then I'm gonna exit. Then I'm gonna go to interface serial 010, and I'm gonna say IP NAT outside. So that's the first step. And then now I'm gonna exit. Now it's time to do the translation. We've got two IP addresses from the two public IP addresses from the ISP. We're gonna be translating our private IP addresses to those two public IP addresses. So I'm gonna be mapping it. I'm gonna map the .5 to 54.1.1.5. So IP NAT. So inside means our local network, the source of our inside. So it's gonna be static. IP NAT inside stores static. So and then our private IP address that we're going to be translating is 192.168. That's the first one. .10.5. Then we're translating that into 54.1.1.5. So and then we say enter. So instead of typing the whole command again, we are now translating the second one, which is the 10.6, the IP address of our server. So I'm gonna just do that. Then I'm gonna change this to 6, and then I'm gonna change that to 6 as well. So that should be that. So that's that. So if I'm gonna go to access our server from the internet now from this PC. So if I try with the private IP address is not going to be accessible. So I'm going to be using the public one, which I can try with the private one first, 192.168.10.6. So that's not going to be accessible. So I can just stop that because it's not going to work. So I'm going to try with the 54.1.1.6. So that is now accessible. So and then we can now go here and see the translation. We go here, say Control Z, show IP NAT translations. So and that's that. So we've got traffic, TCP traffic, because this PC accessed our server on the internet. So and that's the outside local is the same thing, these two ones. So 64.10.10.5 using on port 1026. So he made a TCP connection, which is HTTP. So to our public IP address, which is 54.1.1.6 on port 80, which is the TCP port for HTTP. So, and that's on our inside global address. And then it has been translated to 192.168.10.6, same port 80 for HTTP. So because that's our private IP address that we've mapped this public IP address into. So that's fine. So what else we can do is to now do a trace route to just to generate some more traffic and then do a ping as well. So we can now still verify that we show IP NAT translations. So what we'll do here is to go to run, let's say ping 54 .1.1.1.5. Ping 51 54.1.1.5. So I don't know. Oh, that's too long. That's too long. That was a mistake. Yeah. So yeah. So that's correct. So we've got a ping done. Then we can now do a trace route from there. Trace RT. So that's 54.1.1.5. So just to generate some more traffic, and then we're gonna do a trace route from the router, from the ISP router as well. So the trace route from PC uses ICMP protocol, and then from the router uses UDP protocol. So we're gonna say trace route 54.1.1.5. So then we'll show IP NAT translations again here, and then we'll see those traffic. So we can see from that UDP protocol, the trace route that we did from the router, from the ISP router, we can see the IP address that is coming from. That's the 201.145.12.2, which is the IP address of this. It uses UDP when it's doing trace routes from the router. And then the trace route from this PC, the outside local, is a 64.10.10.5, which is this address. And then it's translated it into our inside local. It did it with our inside global address, and it's translated it to our inside local, so which is the 192.168.10.5. So on this port 33, on port here, that will be 33,434. Yeah, and then the same port number here as well, a different port number here. So and we've got the inside global as well here with the ICMP, the initial ping that was done, and then this one is for the trace route from the PC. So the inside global is simply our inside IP address, and then the global means the way how it is seen on the internet, because that's a public IP address. And then the inside local means our private IP address, how it is seen within our local network. And then the outside local is the IP address of the outside of the internet, how it is seen within the local network on the internet. And then the outside global is the IP address on the internet as well, and how it is seen by the rest of the world on the internet. So if you find this video helpful, give it thumbs up and subscribe to our YouTube channel. Until next time, see you in our next video. Thanks. Bye.